two forms of a linear function. One is ax plus by equals c. The other is y equals mx plus b. The first is known as standard form, and the second is known as slope-intercept form. I want to focus today on the y equals mx plus b equation of a line. Now there are a few terms that we're going to need to know. The first is slope, which is represented by the m in this equation. Slope is defined as the ratio of the change in y over the change in x. The next term is y-intercept, which is represented by the b in my equation. Y-intercept is defined as the point at which the function crosses the y-axis. Increasing is another important word, which we define as the x value gets bigger, the y value gets bigger. And if we have increasing, of course we have to have decreasing. And the definition of decreasing is as x gets bigger, y gets smaller. Now let's focus on m a little bit. There's a lot going on with m, or what we call the slope. The first thing is, if the absolute value of m is greater than 1, then the line is steeper than the parent function. Steeper refers to it changing at a faster rate. It has a faster rate of change, or a greater rate of change. Similarly, if f is between 1 and negative 1, then the line is less steep than the parent function, meaning it's going to be more level or flat. Here's an example of what I'm talking about as far as steepness goes. The red line is known as our parent function. Every point on that line, my x and y are equal to each other. The blue line, if you'll notice, has a m value of 5, which is larger than 1, so it's a very steep line. The green line, however, has a slope of 0.25, which is less than 1 and greater than negative 1. So it is a flatter line than the parent function. M also controls whether the line will be increasing or decreasing. If m is a positive number, the line is increasing. If m is a negative number, however, the line will be decreasing. If we look at the following examples, you'll see what I'm talking about. If you'll notice, here we have the equation of a line. It says y equals 2x, and it says that my m value is 2. Notice 2 is a positive number. If you look at the line on the graph, I have an increasing line. My x is getting bigger and my y is getting bigger. So since it's a positive 2, I have a positive increasing line. In this example, my m is a negative 3. My m is a negative number, so we have a decreasing line shown on the graph. Now let's look at an example of how to identify our slope and our y-intercept by looking at the graph. Here's my parent function. Now, we already know a little bit about the parent function, but let's just prove that it does indeed have a slope of 1 and a y-intercept of 0. If we look for slope first, we remember that slope is the ratio of change in y over the change in x. So I choose 2 points on my line. First, I look at the change in y, my vertical change, which in this case is 3. Then I look at my horizontal change, which in this case is also 3. And that ratio, 3 to 3, gives me a slope of 1. The next thing I do is look for my y-intercept. Y-intercept is the point at which it crosses the y-axis. This function crosses the y-axis at 0, 0, so my y value is 0. If I plug those back into my equation of the line, my 1 goes in front of my x, then I have a plus 0, which we know can be simplified simply to say y equals x. Let's watch this next example. The equation of the line is up in the top left, y equals 3x plus 2. my slope is identified, and my b is identified. Let's see how they got those numbers. Let's see one more example, only this time with a negative slope. And if you'll notice, the slope is between 1 and negative 1, so it's a relatively flat line. The equation is in the top left. Our slope is identified as negative 0.5, and our y-intercept is identified at negative 3. Now, notice my vertical change is actually a negative 3 because I'm going down on my y values. Now I'd like you to try one. Identify the slope and the y-intercept to write the equation of this line. First, you might have found your horizontal and vertical change. And you remember that slope is the vertical change over the horizontal change. And in this case, 6 divided by 3, that ratio would simplify to 2. So our slope is identified as 2. Then we find the y-intercept. In this example, it crosses at 0, 0. So my y-intercept is 0. The final step is remembering that our equation of a line is y equals mx plus b. We then plug in the values we just found, and we simplify the equation to look like y equals 2x.